Let's have a look at this Math Method Exam 1. Question 1. Find and factorize dy dx for y equals to x times e to the power x squared plus 1. So use product rule. dy dx equals to 1 times e to the power x squared plus 1 plus x times e to the power x squared plus 1 times 2x. That is the derivative of e to the power x squared plus 1. And eventually can take out an ex squared plus 1 times 1 plus 2x squared, okay? Notice that there is another possibility to split out e to the power of 1. Could be e to the power of x squared times e times 1 plus 2x squared, something along this line, but I don't think that's necessary. Let f of x equals to x cubed over log ex. Evaluate f dash at x equals to e. So use quotient rule. U dash is 3x squared times log e of x minus x cubed times 1 over x. That's the derivative of log divided by log e of x whole thing squared. In this case, we cannot bring in the 2 like write it like log ex squared. It's a whole log term squared. Just do a step for factorizing or canceling. 3x squared times log ex minus x cubed divided by x, that's x squared, over log e of x whole thing squared. Then we make a substitution step. F dash of e is 3e squared times log e of e minus e squared divided by log e of e whole thing squared. Notice that log e of e is 1. This will also be 1. So eventually you just get 2e squared, I suppose. Okay, I suppose that's the answer. And next one. Question 2. Consider the simultaneous linear equations ax plus 2 minus a times y equals to 3. X plus a times y equals to 2a plus 1 divided by 2. Find the value of a for which there are infinitely many solutions. So I will take the ratio method. Let's say the coefficient of x has a ratio a divided by 1 should equal to 2 minus a divided by a. Also, a divided by 1 should equal to 3 over 2a plus 1 divided by 2, something along this line. So I need to make sure I find the value or values of a to satisfy both equations. And then I should get a squared equals to 2 minus a, and a squared plus a minus 2 equals to 0. And a plus 2 times a minus 1 equals to 0. And a equals to minus 2 or a equals to 1. Let's check the other set of equation. So I should get, this can be simplified to 6 over 2a plus 1. And across multiplying, we should get 2a squared plus a equals to 6. So 2a squared plus a minus 6 equals to 0. Factorizing, we have 2a and a. Let's use a 3 and a minus 2, or actually minus 3 plus 2. So that's giving me 2a minus 3 and a plus 2 equals to 0. A equals to 3 over 2, or a equals to negative 2. So for infinite solutions, my a value should equal to negative 2. To find a common solution satisfying 3 ratios. Okay, find the values of a for which there is a unique solution. Need 2 gradients not equal to each other. Pretty much is coming from the opposite of these 2 numbers, okay? So a belongs to all real backslash negative 2 and 1, okay? Because if you rearrange the equation, you should get, let's say, m1. The first gradient is minus a divided by 2 minus a. And the second equation should give you m2 equals to minus 1 divided by a. If m1 is not equal to m2, that means your a value is not equal to -2 or not equal to 1. And we write down the full set of real numbers. A belongs to Oreo / excluding -2 or 1, okay? Part C, find a value of A such that the lines meet at right angles. So we could actually say, okay, gradient 1 times gradient 2 equals to -1, something like that. Then I should get -a divided by 2 minus a times -1 over a equals to -1. So you should get a 1 over 2 minus a equals to -1. And a minus 2 equals to 1. So a equals to 3. The good thing is the question only asks for one value of a rather than all values. Because if you pay attention to the two equations, you could actually see, let me just rub this out and make a snippet here. Save the picture. Okay, special case. If 2 minus a equals to 0, a equals to 2, line 1 is 2x equals to 3. X equals to 3 over 2. It's a vertical line. Then your line 2 will become, let's say, x plus 2y equals to 5 over 2. Clearly, this is a perpendicular line to the x-axis. And this line has some slope there. So they are not perpendicular to each other, these two lines. The other case is if a equals to 0. Well, we can still get two lines because line 1 will become 0 plus 2y. 2y equals to 3. So y equals to 3 over 2. And line 2 will become x equals to half. Pretty much, if you plot them, this is y equals to 3 over 2. This could be x equals to half. They do meet at a right angle, okay? So the full answer, if the question says find the value, it should be the values of a. Then you could get a equals to 3 or a equals to 0, okay? So that's what I'm thinking. But you only need to specify one value, okay? Question 3. F of x is 3 log e 2 minus x. D is the domain of f. Specify the maximal domain for f of x. All I need to make is 2 minus x greater than 0. So x is less than 2. Therefore, x is an element of -infinity to 2. Or you could say d equals to -infinity to 2. Sketch the graph of y equals to f of x, labeling the asymptote with this equation and the axial intercept with their coordinates. Interestingly, the exam writer did not provide any grids. So you need to make a judgment yourself. For example, the vertical asymptote must be x equals to 2. So let's say if this is 1, this is 2. I'll just rule out a vertical line here and specify x equals to 2. All right. And now if I sub in x equals to 0, f of 0 is 3 log e of 2. Okay. So like I know 2 is slightly less than e. 2 is less than e. So log e of 2 is slightly less than 1. Okay. And it's roughly, let's say 0.7 something, 0.8. And then you will get let's say something on this line, 3, 2, 1. Maybe my y-intercept is here. Okay, and next thing is you make your y equals to 0, which is 3 log e 2 minus x equals to 0. And log e of 2 minus x equals to 0, something along this line. Now, you could get log e of 1 equals to 0. That's why you can equate 2 minus x to 1. Therefore, your x is exactly 1. All right? So, sketch the graph here. I suspect you can sketch a log graph like this. Okay? Something along this line. Okay. Now, find the values of x for which f of x is greater than or equal to 0, but are smaller than or equal to 3, based on the graph we just plotted. We know this is like 1 for the x value, and this is y equals to 0. And also, if you plot a horizontal line, y equals to 3, there is another intersection here, which is like giving you a negative x value. So you could say 3 log e of 2 minus x equals to 3, and log e of 2 minus x equals to 1. Therefore, 2 minus x is e to the power 1, and x is like 2 minus e, okay? 2 minus e. So it's between here and here, this section, okay? That should be the answer. All right, so another lovely exponential log question with some algebra. Yep, I've got the axial intercept, I've got the asymptote labeled with the equation, and I've got a reasonably accurate shape. Should be fine. Let's move on. G of x is a log function. Domain is 3 over 2 to infinity. H of x is an exponential function with domain all real numbers. Show that G composite H is defined. This is not G times H. This is G of H of x. Okay? So let's look at the range of the inner function. It must be 2 to infinity, because if you plot a quick graph here, this is y equals to 2, x equals to 0, y equals to 3. Okay, so that is the graph of H of x. And domain of the outer function g is 3 over 2 to infinity. Okay, as 2 to infinity is a subset of 3 on 2 to infinity, range of H is a subset of domain G. Therefore, G of H is defined. Okay, so I suppose that is using the range of the inner function as a subset of the outer function to make the composite function defined. Find the range of G of H given the domain of G of H is x belongs to R. So let y1 equals to G of H of x. This is what I'm going to write first, because I want to make some consistent notations throughout the question. That is technically, let's say, log e of 2 times e to the power 3x plus 2 minus 3, okay? And simplifying, you get y1 equals to log e of 2e to the power 3x plus 1, all right? So let's analyze the behavior of this function. X belongs to negative infinity to infinity for all real numbers. If x approaches to negative infinity, look at the argument here. 2e to the power of 3x plus 1 is approaching to 2e to the power negative infinity plus 1. And this bit is negligible because e to the power negative infinity is like 1 over e to the power infinity, which is approaching to 0. So eventually, we just approach to 1 for the argument. And the y1 is approaching to log e of 1, which is approaching to 0, something along this line, okay? And also if x equals to 0, y1 equals to log e of 2e to the power 0 plus 1, which is log e3. And once we get x approaches to approaching to infinity, your 2e to the power 3x plus 1 as your inner argument, we approach 2e to the power infinity plus 1, which is still an infinity. And y1 is approaching to log e of infinity, which is also infinity. So eventually the range of GOH equals to 0 to infinity. Of course, the 0 must have an open circle rather than a closed circle. It approaches to 0, but never equals to 0, okay? Alternatively, you may just want to say, okay, let y equals to g of h, but you're not writing x down. And then you just get y equals to log e of 2h minus 3. For x belongs to all real numbers, your dummy variable h or inner function will be, let's say, 2 to infinity. So when h approaches to 2, your y approaches to log e of 4 minus 3, which is log e of 1. And that is 0, okay? So y approaches to 0, and h approaches to infinity. Y is also approaching to natural log infinity, which is infinity. That's how you get the range. R plus, okay? Same answer, different approaches. All right, question 5. In the nursery, 90% of the seeds will grow into seedlings. P hat be the random variable representing the sample proportion of seeds that will grow into seedlings for sample of size 100. Find the mean and the standard deviation of P hat. So pretty much your population proportion is 0.9, and 1 minus P will be 0.1. N equals to, let's say, 100. So expected value of sample proportion will be small p, which is 0.9, okay? And once you get the mean value, you get the variance first, and then take the square root. This will be p times 1 minus p divided by n, which is 0.9 times 0.1 divided by 100. So I would write this as 0.09 divided by 100, which will be 0.3 divided by 10 squared. Therefore, the standard deviation p hat is going to be 0.3 divided by 10, but I can't write it as a mixed fraction with both decimal and a whole number. It has to be 3 over 100 or 0.03, okay? We'll also write all 9 over 10 here. Let's box them. Mean and standard deviation. Let z be the standard normal random variable such that z is normal 0, 1, and our probability z greater than -1 is 0.84. Using the normal approximation of p hat, estimate the probability that in a sample of 100, more than 93 seeds will grow into seedlings. Give your answer correct to 2 decimal places. First of all, translating the sentence, this p hat more than 93 out of 100, okay? Because it's given by x divided by n here. X is 93 and n is 100. And that is like probability of p hat greater than 0.93 whatsoever. Now, if we treat p hat as if it's a normal distribution, normal curve, under the normal curve. Let's write the p hat here. And let's draw another parallel axis for the z-score. So for example, from the previous part, we obtained 0.9 or 0.90. That's the mean value in the middle. So the z-score in the middle for a normal curve is 0. And one standard deviation is 0.03. So let's say 0.87 and a 0. Let's say 93. Okay. What I'm trying to find is using the normal approximation, this blue area under the curve. And according to the z-scores, I'm just finding, probability of z greater than 1, in this case, for the approximation. And if you notice the symmetry property, let me show you. Maybe I should duplicate everything I've drawn here. That is like when I have a 0 here, -1 here, and a 1 here, the question actually provided me z greater than -1 is 0.84. So this is 0.84, okay? And you could also argue that from -infinity to 1 here, this bit is 0.84. So what I want to find for the blue part must be 0.16, the rest. Okay, so that is the suggested approaches of my drawing diagrams and using the symmetry property of normal curve, okay? Moving on. Right, the 2 decimal places. Yep, 2 decimal places. Decimal form. Question 6. Part of the graph of gx equals to sine 2x minus 5 pi over 6 plus 2 is shown below. Using the trapezium rule approximation method and the 3 trapeziums of equal width, estimate the area bounded by the graph of y equals to gx, the x-axis and lines. X equals to pi over 6, and x equals to 2 pi over 3. Actually, you need 3 trapeziums. So outline these values, okay? And you can see the numbers are nice numbers, either whole number or like 3, 2.5, 1.5, and 1, okay? So it makes our evaluation process much easier than expected. Okay? So I'll mark them down. Pi over 6, 1, pi over 3, 1.5, or actually 3 over 2. Half pi, that's 2.5, or let's just write 5 over 2. And eventually that's 2 pi over 3, comma 3. Okay, let me double check. Yep. Yes. Okay. For the trapezium estimation, you just need to make a clear substitution. Area trapezium equals to b minus a, 2 pi over 3 minus pi over 6, divided by 2 times n. N is the number of strips you have. 1, 2, 3, 3 trapeziums. Times the first y value plus 2 lots of the second y value plus 2 lots of the next y value, and there is a one last y value, which is 3, okay? So you only double up the middle y values with the first one and the last one. You just keep a value for each end. And the 2 pi over 3 minus pi over 6 is half pi. So half pi divided by 6. So that is pi over 12. 1 plus 3 plus 5 plus 3. This one looks like pi over 12 times 12. A very nice number, pi. Okay, part B. H. Let H be restricted over pi over 6 and 2 pi over 3, this domain. And h of x is a dilation of g of x. Using calculus, find k such that h is a probability density function. The question says using calculus, but only 2 marks. There's one thing I probably have noticed here. Look, this part of the curve, of the sine curve, it's not a straight line. So you will have a tiny bit area here and also tiny bit gap here, okay? But they are symmetrical about this value according to the symmetry of a sine graph. This is a point of inflection here. And also this bit exceeds the actual area under the curve. This bit is a gap between the trapezium top end and the curve. So actually you could use tessellation. And what I found as an estimate for these 3 parts, the sum of these 3 parts is pi, which means the area from pi over 6 to 2 pi over 3 will also be exactly pi. But even if you notice this, the question says using calculus, you still have to show some antiderivative. Like, for example, I know the area under g of x is going to be pi. So you could say, okay, pi over 6 to pi on 3. And then you integrate this function. Is that add 2? Yep. I will need to find the antiderivative and sub in the value to show this is actually a pi. Then k must be 1 over pi such that the area under the curve after dilation is 1. This is my rough approach. Antideriving sign will give you minus half cosine of 2x minus 5 pi over 6 plus 2x. Minus half cosine of 4 pi over 3 minus 5 pi over 6 plus 4 pi over 3. Subtracting minus half cosine of pi over 3 minus 5 pi over 6 plus pi over 3 because you're doubling pi over 6. So eventually, let's see how we go. Minus half cosine. Well, 4 pi over 3 is like 8 pi over 6 minus 5 pi over 6. This is a very convenient value, 3 pi over 6, which is half pi. Cosine half pi is 0 plus 4 pi over 3 plus minus minus plus cosine of, let's say this is like minus half pi, if I'm not mistaken, because minus 2 pi, hang on a second, it's not minus half pi, but let's check. Plus half pi over 3, sorry, over 6, minus 5 pi over 6. This is minus 3 pi over 6. Yep, minus half pi, that's correct. And this will be 0, okay? Minus pi over 3. So eventually the area is exactly pi here, okay? Area under h of x needs to be 1 for a probability density function condition. Therefore, k must equal to 1 over pi, okay? So that is my answer. And let's see what else we need to do. Question 7. Let x be a discrete random variable with a probability mass function. I like the phrase here, probability mass function. For discrete random variable, it's probability mass function. For continuous random variable, it's probability density function. This is an interesting one. 2 over 3 to the power x. So find probability x equals to 4. We could say probability x equals to 4 is 2 to the power 3 to the power 4, which is 2 over 81, I suppose, because 99 is 81, okay? And find the probability x less than 4, given x greater than or equal to 2. So that is like probability of x less than or equal to 3 intersecting x greater than or equal to 2. Divided by probability of x greater than or equal to 2. So the numerator is just 2 less than or equal to x less than or equal to 3. And the denominator, well, this is a bit issue here because you've got x belongs to z plus. Technically, you can take x equals to 1, 2, 3, 4, 5, blah, 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 until infinity, endless. Therefore, it's impossible for us to work out endless number of probabilities. Instead, I'm going to exclude the probability when x equals to 1 for the rest. So I'm going to use 1 minus probability of x equals to 1. This is something different to what we are used to, like a 1 minus probability x equals to 0, okay? Because the domain starts from 1 rather than 0. Now all I need to do is chuck in 2 and 3, say 2 over 3 to the power 2 plus 2 over 3 to the power, let's say, 3, divided by 1 minus 2 over 3 to the power 1. That is just 2 over 3, okay? So effectively, we are dividing by 1/3, which is times 3. And then we can just combine the denominators. Three times, let's say a 6 here plus 2 here divided by 27 here. So my answer should be 8 over 9, okay? 8 over 9 should be a very simple fraction. And there is another extra thing I would like to mention here, even though this extra thing is not part of the math method study design. The probability of x equals to x is 2 divided by 3 to the power x. But you could also write it as 2 times 1/3 to the power x, with x equals to 1, 2, 3, 4, blah, blah, blah. And this is called a geometric sequence, okay? Geometric sequence with this given domain. And the initial term, when x equals to 1, the first term is a equals to 2. Common ratio is 1/3. So the infinite sum is the sum of all probabilities equals to a divided by 1 minus r. That is 2 divided by, actually, I should actually write this in this form. Write the expression as 2 over 3 times 1/3 x minus 1. That is called the initial term. So the a value should actually be 2 on 3. And 1 minus 1/3, which is 2 over 3 divided by 2 over 3. Yep, that's 1, okay? Yep, that satisfies the probability mass function condition. The sum of all probabilities is 1. This is actually a very good question. Maybe specialist math students should be able to recognize that, or maybe not. Anyway, let's just move on. Question 8. F is 1 over square root 3x plus 1. Find an antiderivative for f of x. Well, if you differentiate root 3x plus 1, that is 1/2 times 3 times 1 over square root of 3x plus 1. And that will give you 3 on 2 times 1 over square root 3x plus 1. Okay? So if you antiderive 1 over square root 3x plus 1 dx, that will actually give you the, 2 on 3 times square root of 3x plus 1 at C. The question says an antiderivative, so C can be any real number. Or you can just apply the rule here. For example, 3x plus 1 to the power negative half here dx. As long as it's a linear function to a power, you can still use the raising power pattern here. Say 3x plus 1 minus half plus 1. That's half divided by the new power times the coefficient 3. So you actually get 2 over 3, 3x plus 1 to the power half at C, okay? Anyway, just 1 mark. The average value of the function f over 0 to m is 1/3. Find the value of m. So the average value is equal to 1 over m minus 0. Integrating from 0 to m. Equals to 1/3, okay? 1 over m minus 0. And what you can actually do is reuse the antiderivative from part A instead of integrating again. Because all you need to do is 1 over m times 2 on 3. Square root 3x plus 1 from 0 to m equals to 1/3, okay? And you can actually multiply both sides by 3m or whatsoever. So you should be able to get a 2 square root 3m plus 1 minus square root of 1 because you're subbing in 0 equals to, let's say, m here, okay? So 2 square root 3m plus 1 minus 2 equals to m. And the 2 square root 3m plus 1 equals to m plus 2. When you have a linear function on one side and a square root on the other side, the tactic to solve this sort of equation is to square both sides. Say you have 4, 3m plus 1. If you square the left-hand side, and you will square the right-hand side to get m plus 2 whole thing squared. But it's not just m squared plus 4. It's actually m squared plus 4m plus 4, okay? So that will give you, let's say, 12m plus 4 equals to m squared plus 4m plus 4. And m squared minus, for example, 8m. You can cancel out the 4 here. 4m subtracting 12m is 8 minus 8m. And that equals to 0. So m times m minus 8 equals to 0. But m must be greater than 0. Your m can only be 8. Okay? Something along this line. Right. Question 8, question 9. Okay, let f of x be x minus 1 times e to the power minus x with the domain 0 to infinity. Find f dash of x. So f dash of x is simply 1 times e to the power negative x plus x minus 1 times minus e minus x. So e to the power minus x, 1 minus x plus 1. And I should be able to get, let's say, e to the power minus x times 2 minus x. We often write the polynomials first, then the exponential function. So how about we write like 2 minus x times e to the power minus x. And state the sequence of transformations that will map f of x onto f dash of x. This one is a bit interesting here because looks like we've got can I use a reflection? Yes, I could use a reflection. Right. So if I take a reflection here, let's try reflection in the x-axis. Mapping f of x to f dash, I will get a 1 minus x, negative x minus 1 e to the power negative x equals to 1 minus x e to the power negative x. And then can I do a translation? Because I need to make a 2 here, 2 minus x. Translation, 1 unit right. That would be 1 minus x minus 1 e minus x minus 1. And that actually gives me 2 minus x e to the power minus x plus 1. But it's not quite like just e minus x. So I probably will want to do one extra step. 2 minus x times e to the power minus x times e to the power 1. The key is to get this e to the power 1 split out from the exponential term. Then you can apply the dilation here. 1 over e from x. So that will make 1 over e times 2 minus x times e to the power minus x times e. Yep, canceled out. Good. Okay. So according to my working out here, reflection in or about the x-axis. And you can actually do the translation first. Yep. Translation by 1 unit to the right. And a dilation factor of 1 over e. E to the power minus 1 will also be the equivalent form. 1 over e from the x-axis. Okay, so that is question 9. All right, show that ddx minus x times e to the power minus x equals to f of x. So left-hand side is minus 1 times e to the power of minus x plus minus x times minus e minus x. That will give you minus e to the power minus x plus x times e to the power of minus x. And that gives you x minus 1 e to the power minus x using product rule. That equals to right-hand side. Okay, so that's question 9, ABC. This one is quite good. Let y equals to gx be the tangent to y equals to f of x at the point 3, f3. So if I have the point here, f of 3 equals to 3 minus 1 e to the power of minus 3. That will give me 2e minus 3. So that's the point. And the f dash of x is 2 minus x e to the power negative x. So f dash of 3 is your gradient of tangent. That will be 2 minus 3 is minus 1 times e to the power of minus 3. So minus e minus 3. So equation of tangent, yt equals to minus e minus 3 times x minus, let's say, minus 3 plus 2e to the power of negative 3, something along this line. Okay. So the first step would probably be finding the antiderivative of upper minus lower from 1 to 3. But you still need the equation of tangent, I suppose. And what else? So what you can do next is setting out a suitable integration and determine the area of region bounded by the lines x equals to 1, gx, and the graph of f of x from 1 until x equals to 3. So let's just write the suitable working out. Okay, area shaded equals to the integration from 1 to 3. Y tangent is minus 1 over e to the power 3, x minus 3, plus 2e to the power, actually I can write it like plus 2 over e to the power 3. That's the tangent line, subtracting f of x dx. I'm not going to write out the full expression for f of x because I know if I anti-derive f of x, I'll just get a minus x e minus x. So I only need to deal with the linear function with a few exponential term. I'm going to do a split calculation. I treat x minus 3 as a whole term. I will be getting, let's say, well, let me properly explain what I will be doing. So firstly, I will take out a minus 1 over e to the power 3 from 1 to 3. Now we get x minus 3 minus 2 dx here, okay, for the first bit. And then I will subtract integral from 1 to 3, f of x dx. Then recognizing anti-deriving f of x dx gives me minus x e minus x at c, something along this line. So 1 minus 1 over e to the power 3, x minus 3 divided by 2, that's the square term here, minus 2x from 1 to 3. Subtracting minus x e minus x from 1 to 3. Actually, with the minus here, we can just make this an addition, add. So eventually what I can do is minus 1 over e cubed. When you sub in a 3 here, that will be 0 divided by 2 minus 6, right? When you sub in the 1 here, that's minus 2 squared. Okay, so if it's a minus 2 squared, 4 divided by 2, that's 2. And sub in the 1 here, that's 2 minus 2. Plus 3e to the power negative 3 minus 1 times e to the power negative 1. Okay? So what you can actually get is like, this one disappeared, this one disappeared. 6 over e to the power 3 plus 3 over e to the power 3 minus 1 over e. And you just need to combine the answer and make it a reasonable form. So the answer is 9 over e to the power 3 minus 1 over e. Other equivalent forms may include things like 9 minus e squared divided by e to the power 3, or let's say 9e negative 3 minus e negative 1, etc. But just be careful if you are trying to convert your answer in other equivalent form. Say if you made any further mistake, you won't be able to receive the correct answer mark, etc. Okay. All right. So you're required to find the equation of tangent in whatever form, as long as correct, and set out an integral from 1 to 3, upper minus lower, using the given derivative to make an integration by recognition. Just notice the plus or minus changes, and eventually just sub in the value and use the brackets correctly. Very simple. Okay, a lovely exam 1 paper. Hopefully you find this video helpful, and I'll see you guys in near future. Good luck.